You're listening to the Maritime Gardening Podcast brought to you by Vessi Seeds. And today we've got Richard Zurawski to talk about this ridiculously hot, dry summer we've had. Who is Richard Zurawski? He's a meteorologist, a documentary film producer, a TV host, writer, author, Nova Scotian gem, man of science, university lecturer, public speaker, and media personality. It's been a ridiculously dry summer here in Nova Scotia, hottest I can recall, real challenge for gardeners. And because Richard is such an accomplished meteorologist and also just a man of science, I thought I'd have him on to talk about this drought and what's going on with all this stuff. So Richard, say hello.
Hi, how are you? I don't know who you were talking about, but I'm happy to sit in and talk about weather and all that kind of stuff. And while you
Great.
were talking, I just brought up a screen from a source of meteorological weather information. I wanted to share this with
Yeah.
you, give you an idea of what's going on off the coast of Nova Scotia. So bear with me. Don't get vertigo as I move the computer, but
Wow. Is this free? Like, could I log into this, or is this like
yes, you can.
special thing you guys have?
Well, it's actually called earth.nullschool.net.
Okay,
And
we'll put that in
so,
the show notes for people that are interested. That's really cool.
yeah, it's fabulous. So you can look at air currents, weather currents, chemical particulates, waves, and all things meteorological. And what you're looking at right now is called SSTA. That is the sea surface temperature anomaly. And I'm
Okay.
trying to operate my mouse here backwards, like it's like doing it in a mirror.
Is this just based
And
on measuring statements, or is it some sort of like infrared satellite? How's
this
the,
is updated every 20 minutes.
oh wow.
This is all satellite technology. The dozens and dozens of satellites that are above the Earth, they compile the information, and this goes through a central computer with the World Meteorological Organization and the various meteorological organizations like the National Weather Service in the States, Environment Canada. And all of this is assembled into these graphical representations. So you're seeing here the red right here. That's the anomaly, how much warmer it is than normal. And some cooler water here is blue. That tells you it's cooler. And then if you look at the really extreme stuff, we've got extreme warmth off the coast of Nova Scotia, goes from red to yellow, and approaching into the Bay of Fundy, in spite of the fact that you've got some cold patches off Cape Cod and Cape
What
Hatteras.
what color is normal on this? Is black normal, or like where?
Black would be normal.
Okay,
And
and
so
then
this is
blue
the,
is colder than normal.
yeah.
Okay.
So this is the temperature anomaly. It tells you
Yeah,
how
yeah.
much out of normal it is.
Yeah,
And so
yeah.
the Southern Atlantic Ocean is the area that you have um, generating our weather in the summertime and in spring, summer, and fall. And we get 25 to 30% of our heat budget comes not from the sun, it actually comes from the Gulf Stream, which is a part of what's called AMOC, the Atlantic Meridional Overturning Currents.
Oh,
And they actually uh, bring up all that heat that make us the Maritimes and keep us warm and toasty in the winter and coolish in the summer.
yeah.
Well, latest studies are saying that this is starting to break down. I'm just going to switch the computer around again.
Yeah, yeah.
There we go. Yeah,
I could sit
unfortunately,
at that thing all
I
day.
yeah, there's so much to look at, and it's disconcerting to see that the studies are telling us that things are changing very, very rapidly, that the likelihood of AMOC shutting down has now gone up dramatically. Another few papers have been written about it. And if that happens, surprisingly, we have the risk of going into a mini ice age on
Really?
the Canadian coast and up and through Iceland, Greenland, and into northwestern Europe if the current shuts down. And it looks like it can. It's much more likely than it was thought to be. But the thing I wanted to focus on more than that is why things are so warm here. And part of it is the fact that we've got extremely warm waters around the Maritimes. And that is contributing to the flow of air not providing the moisture from the ocean. It's actually pushing off most of the disturbances into the ocean. They went south of us, or they stayed way north, and we just baked. We got all kinds of uh, ridge. It's called the Bermuda High, high pressure ridge weather. And the prevailing winds gave us southwesterly, dry, hot conditions because of the way the circulation patterns were set up. And the secondary part of this is the fact that even though the southern oceans are baking, the Sahara Desert has become even drier in this last few decades. And so we've had dust coming off to the Sahara, and it's tamping down the risk of hurricanes, which is good news, which I really don't like to see because we were calling for quite an active season. And so far, it hasn't materialized to the same extent that we had thought it would.
Hey, I have a question for you. I mean, is if you've got this entire, so we've got an ocean that's hotter than normal,
Yep.
which means in principle there's more evaporation than normal.
Yeah.
Where's all the water going?
Well, it's going to other
Why is it
parts of the
coming
world.
back? Okay.
Well, you see, the thing is, everything is interconnected. So
Yeah,
um, you can wind up with anomalies in certain areas. So when you change the flow patterns of the air locally, you can wind up with droughts in places where you traditionally haven't had that. That's what's happened in India and parts of the Middle East. Um, Trade winds, monsoons, that kind of thing, have become less reliable. Our climate is destabilizing, and where the breakpoints happen are hard to predict. As a matter of fact, the modeling for most of this stuff is based on stable climate patterns. And when you destabilize that, the modeling starts to fall apart. You have to rejig the models, you have to reinvent them and start measuring different things. And different things take different priorities. Wind direction can be crucial. Um, for instance, there's been a desert off the coast of South America, Peru and Chile, called the Atacama Desert. It's been a desert for 35 million years, even though um, it's right on the Pacific Humboldt Current. And so no rainfalls, or some areas haven't had rainfall in 300 years. It's the driest place in the world. And that's all to do because of the prevailing winds. Even though it's on the water, it doesn't get any moisture at all. So it looks like Mars. It doesn't look like a normal Earth um,
wow.
habitat you would expect, especially down in South America. So we're starting to experience that. And we're starting to learn about how it affects our weather patterns. And right now, it's been a huge surprise that number one is our predictive ability with hurricanes has fallen off dramatically, it appears.
That's not
And
good.
number two is that we're looking at AMOC maybe shutting down and losing our heat budget. And number three is we wind up with crazy weather anomalies that give us droughts and a lack of rainfall that is astounding. Like we only got in Nova Scotia 25 to about 40% of our normal rainfall over much of the summer, and that's June, July, and August.
I can't recall. I mean, certainly since I became a gardener, I haven't experienced this, but that's like I became a serious gardener in Nova Scotia, let's say 2004. Um, I grew up with gardens and that sort of stuff, but I don't seem to recall, you know, um, just for those that are watching that aren't from where I'm from and that they're somewhere else. I mean, I know a good portion of my viewers in the United States and elsewhere in the world. Um, where we live, I don't know when this happened, maybe June or July. Um, we were told you couldn't go in the woods, you couldn't go hiking, you know you can't have fires in your like where I live in a sort of semi-rural place. I have a well in my backyard and a forest behind my house. This morning, about an hour before I started talking to Richard, there was 10 juvenile pheasants in my backyard eating something on the grass. But I can't go in. Well, I can now because we had some rain in this part of the province. But
Mhm.
for the bulk of the summer, you couldn't have a fire in your backyard. You couldn't go hiking in the woods. You couldn't do anything because there was parts of the province that were just out of control on fire, and they didn't want any more parts of the province out of control on fire. And they also didn't want people being stuck out in the woods when something catches on fire. I mean, just all kinds of reasons. I had no problem with any of that. Um, but it's been, I don't recall. I mean, there was a couple of years ago, we had another fire and we had a similar set of restrictions. But prior to that, I really don't recall that sort of thing happening. And I don't think it has anything to do with the particular governments in power or anything like that. I think they're just trying to make sure we have the resources to handle things.
Yeah.
But prior to that, I remember just lighting fires and doing whatever I want. Um, so it's been just ridiculously dry. I mean, do you know when the last time we had anything like this historically? A
I've
rainfall
been
shortage?
in Nova Scotia for 40 years, and I've been a meteorologist for, oh, goodness, I hate to say, but more than half a century. And I've not experienced this type of weather anomaly. Um, the Maritimes are famous for their consistent moisture
Yeah,
and consistent weather. So in the summertime, if you look at June and July, um, you can get good days and bad days, but basically 2 out of 3 days are sunny, and you can count on one day with rain.
probably on the
And
weekend. Yeah.
yeah, exactly. It falls on Saturday and Sunday,
Yes.
like clockwork.
Yeah.
And in the fall, we get what's called a Bermuda high, which is an area of high pressure, which changes the flow patterns to the deep southwest. And so we wind up with anywhere from 4 to 8 weeks of glorious late summer, early fall weather. And mostly that happens in August and September. And then, of course, we wind up with the winter pattern starting to come in after the autumnal equinox. When the days
Mhm.
get shorter, things get cooler and less sunshine, and other systems start to come in. So, looking at those patterns, I've never seen anything like this. We've had spotty droughts. I remember a couple of years ago when we had the forest fires in Nova Scotia, we also had droughts. There were a lot of people who were trucking in water in the
Yeah.
rural areas to put in their wells, that kind of thing, and they were catching rain and when it did fall. But the drought wasn't as profound as it was this time around. So we have a confluence of things happening. So when the weather patterns set up differently, the flow of air is different. And we're kind of an appendage sticking out in the North Atlantic and very similar to Newfoundland. We count on the effect of the ocean. And this summer, the effect of the ocean did not give us any precipitation. And as you said, it was dry, and some areas got less than 25% of normal rainfall. Um, and that uh, is astounding to me. I mean, we get heat waves, we get certain weather patterns, but nothing that I saw, and especially for this protracted period. And we're still not out of the woods, pardon the pun. Um, Even though we did get some rainfall in the last week, we got maybe 10 to 20 millimeters, which is half an inch to an inch of rain, if you're still an imperialist measurer. Uh, and it is not nearly enough because normally we should be getting about 4 inches of rain per month, or about 100 millimeters of rain through the summertime. That's June, July, August, and we got nowhere near that. So this looks like it's going to continue for the next 3 or 4 weeks. And of course, Halifax Water has put in water restrictions, which they'll be announcing later this week for the residents of Halifax. So our water reservoirs in the forms of lakes. Dartmouth is called the city of lakes. It's got many, many lakes. The hiking region of Blue Mountain Birch Cove has over a dozen lakes, and they're all down dramatically. They're drying up.
Yeah, there's one I drive by. So I take St. Margaret's Bay Road into the Armdale Rotary. People that aren't familiar have no idea what I'm talking about. But anyway, there's a lake right next to the road. I think it might be part of that reservoir system for the Halifax water system, or it's next to a lake that is.
Hmm.
Um, and there must be like, I don't know, high iron content in that water, but you can see the shores receded. I've often thought of doing a video there. Like you can, from where the water would normally be, it's back about 30 feet and it's all red.
Yeah.
It just looks like uh, it looks like it's being drained for some, agricultural project or something. When you see footage of some of these countries that do these agricultural projects that drain systems, um, it looks like that. It's just been so ridiculously dry. And for people that aren't from here, you look at people's lawns. If you're a lawn or grass enthusiast, this is probably, yeah, most lawns. I mean, I'm looking at the lawn in front of me here, which is where my septic field is. So that's looking great. But the front lawn looks terrible. I don't really care. I mean, I always call a lawn as a garden that you feed gasoline and it gives you no food. So everyone's a gardener. They just don't know it. They just have a garden. They feed gasoline. I guess now you can feed them electricity with electric mowers. But yeah, it's been, and no, I mean, I'm on a well here, thank goodness. But we've been, and it's a really deep well because it's a modern well. Like they go so deep with these things. I don't know what it would take for our well to go dry. Um, I got two goldfish ponds in my backyard, and one of them is one I want to retire, and it's shallower and it's dry. I moved the goldfish in it to the other pond. It's just completely dry, just like you see in Africa when it's between the rainy season. It's literally dry,
Yeah.
except there's no alligators in there looking for looking for gazelles that wander by. Um, so yeah, it's been a ridiculous summer, and I'm wondering, is there anything you're aware of or that you see that might, because in the rules we have, they say, well, until October 15th, or if we get rain. I don't even like, if we don't have any rain by October 5th, they're not lifting anything. I mean, there's nothing magical that happens. We need rain. They're just like, we'll review it.
Yeah.
Um, so do we have any reason to believe? Is it because we'll come out of this Bermuda high and the sort of weather patterns were changed such that some of this rain will start coming our way? I assume there's somewhere on the Atlantic Ocean, there's rain somewhere. It's just not coming our way.
That's
You know,
correct.
yeah. So things are gonna start blowing the other way, and I'm oversimplifying here, but
Couple things going on here. One is the rainfall that we expect in the growing season. The other thing is the snowfall. And what we've been noticing in the wintertime is the last time we had an above normal winter was 6 or 7 years ago when we had back-to-back snowfalls that gave us more than a meter of snow every snowfall.
Hmm.
And there was 5 feet of snow in the woods. And of
That
course,
was
when that,
2015. I remember that
my goodness,
specifically.
yes, it was 20, you're right, that was
Yeah,
10 years
it's the
ago.
worst garden I ever had.
Oh,
Um, uh,
so we're not getting that type of weather anymore. We're not getting the snowfall. Last year was not good. We had below normal snowfall amounts, about 40% of normal, and the year before wasn't good either. So the water's not being replenished
right.
because we pump it out, it goes into the lakes, it goes into the streams. And if you look at the lakes and streams, and on Facebook, a lot of folks like to post it. Everything is starting to look desiccated, and the rivers are starting to look like puddles, not
Mm,
flowing rivers. I um, I was looking at the LaHave River, which is in Bridgewater,
it's
which
a
is
big
about,
system.
yes, which is just south of about an hour south of Halifax, and there are parts of it that aren't flowing at all. It's just puddles of water. They look like rocks with little puddles in between the rocks, and
Oh, almost
it's
like a moraine, or those,
yeah,
yeah, yeah.
yeah.
So there's water underneath it probably somewhere. Uh,
Yeah,
yeah.
so the patterns are setting up in a deleterious way for the consistency that we used to like to think about as being always there. The stability of the climate is shifting, and these tipping points and shifting patterns are almost unpredictable. We don't know how they interlace because we've never done the studies on them, because it hasn't been necessary and we haven't seen a linkage between them. Um, and now we're starting to understand how this works. We talk about condensation nuclei to give us rainfall and that kind of thing, like, the particles in the atmosphere around which the water droplet can form, which give
Yeah.
us rain. Well, you'd think the Sahara Desert blowing the sand into the middle of the Atlantic would actually increase the rainfall, but it doesn't. In
Uh,
this particular case, it damps down the development of the hurricane, which picks up the superheated water. And as we were looking at the graphical representation at the beginning of this talk, you see how hot it is there. So your predisposition is to think, oh my goodness, there's going to be a ton of storms, a ton of hurricanes. And so far, that hasn't materialized. Now, that's not to say that it can't, that we couldn't have a torrid latter half. I mean, we're approaching the very apex of hurricane formation in traditional years. So this is when we should be getting them, but I'm looking at the National Weather Service hurricane information, and they're showing nothing for the next week, which is
that's,
at this time of year really surprising.
I mean, in the vernacular, not experts like you, but people like me, our understanding of what causes hurricanes is when there's a lot of heat and a lot of energy, right? You get this
Yep.
accumulation of energy in a massive system like the North Atlantic, and somehow through science it becomes a hurricane. So the images you showed us, that's energy, a ridiculous amount of energy. Um,
Correct.
so do you think we don't have any hurricanes predicted because as you alluded to before, our models for predicting these things are not like, is it possible to have this much heat in a system like that and it not make hurricanes?
Well, where does the heat go? So the heat, about 85 to 90% of the heat is in the ocean. And with that circulation of water, what's happening is it's going both to the Arctic and the Antarctic, and that heat is being absorbed by the ice and it's melting.
Yeah, yeah.
And so you go, okay, so there's going to be hotter temperatures in the Arctic and Antarctic because it's melting. But then you have to consider the fact that what is happening is the albedo may be changing and it's absorbing more heat yet again because it's not white and bright and reflecting all the energy off into space. But that cold, fresh water will cap the warm water underneath and push those currents to other parts of the world, and specifically probably back into the tropics where it gets even drier. We've been recording temperatures um, in Iran, for instance, in Saudi Arabia, in parts of India, where humidexes, along with plus 50-degree temperature Celsius. Now, if you're measuring temperatures in Fahrenheit, 40 degrees Celsius is 104 degrees, and 50 degrees Celsius is 122 degrees Fahrenheit. And we're talking humidex values in the mid 60s. So you're going to 140 to about 150 degrees equivalent. And for a person to go outside in that it's the equivalent of walking into a sauna, and you could live about 20 minutes to an hour before it would cook you without those types of temperatures. So where the heat pops up is no longer as predictable as it was before. So the heat is definitely there. You're absolutely correct. But you've got all these secondary effects which come
Hmm.
in, and it's sort of like playing whack-a-mole. You, you put your hand down or your mallet down on the one mole and it pops up someplace else. And you go, oh, gee, we didn't consider that. And we've got to put that into the modeling. And we're getting good at it and we're getting better at it. We know the long-term effects, but specifically when it comes to weather, which is kind of an hourly, daily kind of measurement of what's going on in the environment that we live in, it's becoming less predictable because of that.
Um, I think it's also, I'm curious to see what you think about this. My kids were asking me like, why are there so many forest fires and that sort of thing, and I was saying, well, our ecology here in Nova Scotia, we have a particular species of tree that really likes to grow here. And often my viewers will say, you know, it's raining where I live. You don't understand. It's raining where I live. And I always say, look, where I live, it's pretty rainy too. We've got trees that grow on rocks here. You could take a walk behind my house and you could find a huge granite rock, maybe 6 feet high, and you'll see a spruce tree growing on top of the rock. Um, Finding water in this moss that grows on the rock. We normally have so much moisture here. And as a result of that, we've got a lot of these types of trees that are really good at surviving in poor soil, like spruce trees, like fir trees, like tamarack trees. But they also happen to go up like gasoline
Yeah.
when they're, if I could choose the forest that's surrounding my house, I'd want a hardwood forest around my house because even though we like hardwood for our wood stove, um, yeah, a maple tree is not going to burst into flame the way a pine tree will or a spruce tree, right?
Well, conifers are full of what's called creosote, and it's interesting. You noted that when you're driving past the lake, that it looked like it was full of iron. Well, what you're actually seeing is the tannin
Tannins, yes.
that's staining the rocks. So they all look like they're made out of some sort of iron oxide,
Yes.
and it's actually the tannin from the conifers. And the storms that we do have bring down the conifers because they have shallow root systems because there's no soil, and they're basically uh, carbon bombs waiting
Yes.
for a fire. And until they're completely, if you have wet weather, the fungus will come in and eat it up very quickly. Probably in 15 to 20 years, you wouldn't even notice there's a log lying in the forest. But when you have droughts like this, you no longer have the fungus being able to consume the wood the way it might have before.
Mm.
And this adds another added problem so that when we do get fires, they burn hotter, they burn longer, and they're much more difficult to put out. And they've got much more fuel because we've had less rainfall.
Yeah. Yeah. So it's not, I mean, our ecology is not set up for this. I always think of like places like Florida. Well, it's hotter there. Why isn't that catching on fire all the time?
Yeah.
And, but I guess they have a different ecology or it's damper there or
We
I
also
don't
have
know.
what's called a silviculture going on, where there's a difference between a healthy forest and forestry, which is basically growing the type of wood that you want for a specific economic model. And in the Maritimes, we pulp our wood and we like to have spruce and tamarack and pine and hemlock because it's soft wood and it makes paper. And um, that pulp is very uh, it makes a lot of money for people.
Yes.
And so we don't plant succession trees and we don't allow them to develop into succession forests, which is going from conifers to various other types of deciduous trees, which might be, oh, I guess it's pine and birch that start first, then the conifers come in.
Alders as well.
Yeah, and the conifers actually the tannin stops other trees from growing. You'll notice a pine forest doesn't have much growing except for
Just
pine.
pine. Yeah.
Yeah,
Yeah.
it protects itself. And so when you start having deciduous forests making inroads like maple and oak and other types of deciduous trees, that takes a couple of hundred years, and we don't let things go that way without exploiting it.
Oh, and those different, yeah, there's a place I like to go fishing. You have to walk down this long logging road, almost an hour's hike. And at, various portions of the forest, they'll just clear it out sort of thing. They don't take the whole thing. They'll take a section, right? Take a section here, a section there. And then you see things start to grow back. I've been going to this place for 20 years. You see this tree start to go back, and then you'll notice that the silvicultures come in. So when it starts coming back, you'll see spruce trees, pine trees, alders, and birch and maple. And then when the silviculturists come through, you see all that birch and maple and alder just down. They just,
Yeah.
they let them grow about 8 feet high because I think the alder is nitrogen fixing, so it's good. Like you're going to get a better lumber harvest with all the nitrogen. So let those grow a little bit, but then they take them all out. You see them laying down, which is probably really good forest fire stuff, especially all that dead birch bark lying around. That's good stuff for starting fires. And then all of a sudden, the forest is just spruce trees again. They probably wait like a good 30 years or whatever, however long they wait to harvest those for pulp. So it's yeah, uh, we're everything is set up for fire. It's just begging, and then not only that, you got that duff, that about 12 inches of ground that you're walking on. That's like a cigarette, uh,
Yeah.
sort of fine pine needles and stuff, layers and layers of almost like a peat. Or it burns. You can take a chunk of it off the ground and throw it on a fire, and it glows hot. It doesn't burn as well as wood, but it's flammable, right?
Yes, it is.
Molders and all that stuff. So I guess the question is, do we have anything positive? So like, going into September, October, is there anything you're aware of that's gonna change things and get some rain coming down and
Well, we're hoping with the shorter days comes less energy influx,
yeah.
and that causes the ridge of high pressure, the Bermuda high, to move off.
Hmm.
So it established itself early in June, July, and pushed out most of the weather systems that would have given us some rain. And so what I'm hoping is, as the Earth's tilt starts to move away. And the surprising thing is, we're getting closer to the sun in the northern hemisphere as we go into the winter months.
Hmm.
It's the tilt that determines the amount of heat that we get and the amount of insolation or sunlight that we get. So as that happens, I'm hoping that that ridge of high pressure breaks down. And actually, I'm just going to show you the circulation
Sure.
of the ridge of high pressure right now. I'm just going to fix something here, and there we go. Now this is the ocean wind patterns. So
Wow.
it's completely different. You can see the cold front here that has gone south of Nova Scotia. That's why we're in cooler air, and this is the flow that we were getting.
Look at that line. That's the Gulf Stream. That blue line.
No, that's actually a cold front. This is not, this is air now. We're not looking at the
Okay.
ocean.
Okay.
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 So
Sorry.
this is the airflow,
Yeah.
and this is what was called the Bermuda High. A couple of days ago, here's Bermuda. It
Yeah.
was sitting on top of there. Now it started to migrate
Uh,
off into the mid-Atlantic, and so it's allowing other systems to come in. So we are getting kind of a westerly flow here and northwesterly flow with low pressure systems coming in. So I am hopeful that as you can see this huge gyre of air slowly flowing around, and this is the Azores right
yeah.
here, the Canary Islands, and there's Africa with the Cape Verdes and the Lesser and Greater Antilles of the Caribbean. But it shows you the flow pattern, and I'm hoping that this sticks around. We got the rain because the ridge of high pressure moved off
I see.
into the east. And I'm hoping that those are the types of weather patterns we get. But this is a fascinating website. It's called earth.nullschool.net.
Right.
And you can look at so many different facets of it. They look at 1,000 millibar, 850, 700 millibar levels, and they look at chemical constituents, particulates, ocean, air, wind, waves, all that kind of stuff. And it's upgraded every 20 minutes as
Wow.
new information comes in.
Is what we're observing here? Is this when we're in school and we're learning about Jacques Cartier and Christopher Columbus, and we're learning about trade winds. There's like
Yeah,
one way to come, one way that they would go back a different way than they came because they were there's the age of sail. Is that what we're looking at here?
exactly. So these
Yeah.
are the trade winds right here. So all they had to do was this is Spain over here
Yes.
and
It's the
Africa.
Straits
Just
of Gibraltar. Yes.
catch the trades and it would take you here. And then to come back, you'd go north And that it
Yeah.
was hard to get to North America because you had to use different sailing techniques and more sophisticated sailing techniques because of the
Yes.
sailing winds.
Yes. Yes. Geez, I mean, it's amazing that they could even. I mean, this would have been theoretical at the time. Like
Well,
you're looking at it, but
yeah, it's amazing what satellite technology does and ground-based technology. So all of this is compiled and we get a good understanding of the flow. But I thought it was interesting to look at the airflow patterns as opposed to looking at the ocean patterns. It
yeah,
shows you a completely different picture. And I find this kind of stuff fascinating. I will sit here and look at this stuff for hours. I don't have much of a life. Um, and look at weather patterns.
surprise. I don't know if you ever seen the iconic YouTube video called Double Rainbow. You know what I'm talking
Oh,
about?
yes.
I wonder if that guy was looking at that, what his reaction would be. Oh my
But
God! Oh my God!
it,
Uh,
it's oh, maybe I'll give you one more picture here.
sure, yeah.
It's I've just called up the this is the ocean current. Okay, so this is AMOC. This is what it looks like right now. Okay, can you see that?
Yeah.
Okay, so this is the Gulf Stream here, and
Okay.
it flows here and it breaks into various eddies and whirls.
Hmm.
And you can see how warm it is, and
That's
it's going.
heat, that red. Yeah.
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 And so the blue part is cooler, but you've got currents within currents, and this is what warms us. So when we get weather coming off this, it warms, it moderates the Maritimes and Northern Europe. And you can
Uh,
see it goes off into Northern Europe, and it's cold up here because this little tip, I'm gonna just, can I make this smaller? There we go.
that's Greenland there. Yeah.
Yeah. So you can see Greenland is all blue and it just doesn't reach. And you can see parts of it here going to northern British Isles, Ireland, Scotland, and Iceland,
Iceland.
and
Yeah.
Norway. So you can see they're influenced by it. So if this shuts down, they're in trouble.
I see. So okay, I see what you mean. So that shuts down. All of a sudden, everything looks like that spot just south of Norway, Greenland.
Yeah. So
I
it gets
see.
cold. So we wind up with a mini ice age until it's done doing that. And then we'll start up again. But that would take thousands of
That's
years.
geological time. Yes, it's not.
Yeah, it's
It's
not
not good.
not good at all. Anyway, these are the analysis tools that we have, and they give you kind of a snapshot of what's going on and why we're getting this weather, and trying to piece together what affects what and to what degree it affects it is really the question mark. And that's a higher pay grade than either of us have.
That's certainly me. Yeah. Well, that's great. You've given us some. You've explained what's going on. We understand it, which is always. I always prefer understanding to fear. And you've given us uh, some hope for a little bit of rain. And I mean, our gardening season's over. Some people have had, I guess, disastrous gardens. Um, Mine, I had a fantastic garden this year, just by sheer fact that I was able to keep it watered and by using mulch. I don't have an irrigation system in my garden. I did a video where I showed how I water my garden with my kids, where they're running back and forth to. I got a little pond in the garden.
Yeah,
They're running back and forth to me with these gallon cans, and I'm watering each bed. But I only did that maybe 4 or 5 times this whole summer.
yeah,
Like, so I was able to keep, but all the beds are mulch, right?
yeah,
And I also just, you grow a lot of things that are good at finding water. You choose varieties that are good at developing root systems, that sort of thing. You're not trying to grow lettuce in July. That's not, you grow things that are easier to grow.
yeah.
Um, but yeah, this season's over. I don't know what next year is going to be like. But I really should do a video on the merits of keeping the garden mulched, because viewers often say, well, that mulching system, it works where you live, where you get rain all the time. It's not as rainy as England, but it's kind of like that, and it's, compared to other places. But this summer we were like a hot, dry place. We didn't get a lot of rain, and the system held up. I still had to water, but I didn't have to water every day.
Yeah.
So anyway, Richard, thank you so much for doing this. You've given us all that last visual you showed, you see the thing moving off. Okay, maybe this is going to just leave us and things are going to get better. That's good. That's good to see.
Okay.
Everybody
We'll
out
do
there.
our best.
Yes, everybody out there, I hope you found this interesting. If you did, please like, share, subscribe, and until next time, get out there, get at it, have fun in your garden. Richard, thank you so much for doing this.
My pleasure, Greg.
Great.